Alright students, today we're going to start Unit 8 and it's on quadratics. And today we're going to do Section 1 and it's identifying quadratic functions. So a quadratic function is a function that can be written in the form y equals ax squared plus bx plus c, where a, b, and c are real numbers, and a, your leading coefficient, cannot be 0. Because if your leading coefficient is 0, then you don't even have the x squared. So in order for it to be a quadratic function, you've got to have an x squared there. Alright, so we have this example here of this function, and we want to know if it's a quadratic function. We need it to be in this form. And can we tell if it's this form? Well, do we have an A equals 2? Do we have a B equals 4? And do we have a C, our constant? C equals -3. Be careful on this one because that's a positive C, therefore this is a -3. Alright, so we're going to start out and tell whether these are quadratic functions, and we're also going to have to explain why. Okay, so the first step is we want to get this in our quadratic function form where y is isolated. So to isolate the variable y, we need to subtract 3x squared from both sides. So y equals -3x squared minus 4. So is this in quadratic function form? Well, our A is -3, B, let's wait on B here for a minute, and C is -4. So, some people are saying we don't have a B, so it's not a quadratic function. Guys, remember if there's a 2 here, it's a quadratic function. So, what we can do here, can we not say B is 0? Because 0 times x equals 0. And if you add 0 to this equation, it doesn't change the value. So, therefore, yes, this is, and the explanation is because A equals -3, B equals 0, and C equals -4. Okay? Alright, let's look at this next one. Again, we need to isolate our variable y first. So let's subtract 2x from both sides. So y equals a -2x plus 4. Okay, so do we have an A on this one? Do we have a coefficient in front of x squared? And we do not. Therefore, it is not a quadratic function. Okay? Because A cannot equal 0. Can't have that. Alright, let's look at number 3 there. Is our variable y isolated? No, so let's do that. In order to do that, we're going to add 7x to both sides. Okay, so I have 3x squared. I cannot add 7x to that because they're not like terms. And then my 7x and my +2. And on my right side, I have y. Okay, is this in the quadratic function form, where you have ax squared plus bx plus c equal to y? It is. Because a equals 3, b equals 7, and c equals 2. Okay? Alright, now what we're going to do is we're going to make a table and we're going to graph this quadratic function. And we kind of did a little bit of this at the beginning of the year when we were dealing with equations and inequalities, okay, in systems. So, when you make your table, because we're talking about quadratics, you want to try to have where you can see the change in your parabola, whether it's upward or downward, okay? So if you don't know what to start with, always start with -2, -1, 0, 1, and 2. And what we're going to do here is we're going to substitute -2 in for x. So I have 2 times -2 squared. Well, -2 squared is 4, so y is 8. So on this point right here, I'm getting -2, 8. So I can go ahead and graph that, -2, 8. And there's my first point. Now we're going to substitute -1 in for x. -1 squared is 1, and 2 times 1 is 2. So this ordered pair is -1, 2. Now we're going to substitute 0 in for x. So this point is right at the origin, and then we're going to substitute 1 in. And then we're going to substitute +2 in. Okay? Now, when we make, when it's in quadratic form with the x squared, remember it's a parabola. It's like a U. When it's absolute value, that's where you get the b. So try to put a curve in your U. And that wasn't too good, but try to put a curve down here instead of a B. Okay? All right, let's see y'all do the next one on your own. Got to do the same thing. Okay, this one's going to be off the graph a little bit. Okay, guys, let's move on. All right, so the value of A will determine which way the parabola will open. If A is greater than 0, it will open upward. If A is less than 0, it will open downward. So what we're going to do now is we're just going to explain if the parabola is going to open upward or downward. We're not going to have to graph it, okay? So, on this one, our A equals what? Our A is the coefficient in front of your x squared, so A equals 4. It is positive, therefore it opens upward, because A is greater than 0. Okay? Now, before we can see what A is, we need to isolate our variable y on this one, and y is not isolated, so let's do that. So we have y equals a negative 2x squared plus 5. So A equals negative 2, the coefficient in front of x squared. So A is less than 0, therefore it is downward. Okay? All right, let's look at this last one. We need to isolate our variable y by adding 5x squared to both sides. So A equals 5. A is positive. A is greater than 0, therefore it is upward. All right, let me check the time here. And guys, I'm going to stop. We only have 3 problems left, but I want to make sure I have time and start a second part. So I'll see you in just a second.